Hello everyone. Welcome to the Data Science Summit Machine Learning Edition. My name is Indira Bandari and I'm a data architect working in a company called Data Engine, and I'm also a Microsoft MVP. Today I'm going to cover what vectors are, and the title of the topic is From Vectors to RAG Systems. Before proceeding further, I would like to introduce myself. I have a master's degree in statistics, and I have a passion to teach kids all about technology. And I have been teaching SQL and Power BI to 10 to 15-year-old kids. And if you work with kids, they do amazing things these days. So I enjoy working with those kids. And this is the reason I floated a charitable trust called Kids Tech Charitable Trust. And if you would like to contact me, you can contact me on LinkedIn or Twitter, or my blog is mytechlearning.blogspot.com. Now let's look at the agenda today. What I want to do is I want to cover what an LLM is, and there are some limitations for the LLMs. We will see what the limitations are and how we are going to overcome the limitations with a technique called RAG technique. And also we will learn what a vector is, what vector search is, and I'm going to demo you with a low code solution as to how we can create those vectors that we are talking about, vector embeddings that we are talking about. Okay, now let's look at what an LLM is. LLM is nothing but a large language model. So it is an AI program that is particularly good at understanding the human language that we are talking about, and also generating human language. So these LLMs are trained on massive data, which include books, articles, code, and even conversations. And also some of the LLMs are trained on even audio files. They are built on neural networks, which allows the LLM to identify relationships between words and concepts. And these LLMs perform a variety of tasks with language, such as generating text like poems, code, script, musical pieces, emails, and letters, to name a few. And what are the examples of LLMs? You have already, all of you must have used the GPT 3.5 in ChatGPT, and also GPT 4, and there are other large language models such as Mistral and Lava and other examples. Now let's look at some of the limitations of LLMs. Now I have asked question in my application, in my LLM application, who is the Prime Minister of New Zealand? This is using the GPT 3.5 model, large language model, and the answer that I got was, as of September 2021, the Prime Minister of New Zealand is Jacinda Ardern. Who is the Prime Minister now? The Prime Minister of New Zealand now is Christopher Luxon. So this does not match with the current one. So what does that tell us? So LLMs are they don't have latest public knowledge. So they have outdated public knowledge, because they are trained on only the knowledge up to GPT 3.5 is trained on only the knowledge up to September 2021. And I asked another question called, what are our company's core values? My company is Data Engine, and I want to know what are the company's core values. Then it said, the LLM returned the answer saying, I'm sorry, but I don't have access to specific information about your company's core values. You would need to refer to your company's official documentation or website to find that information. So what does this tell us? So you cannot use your own company data or internal knowledge with the large language models that are out there now. So these are the main two limitations of large language models. Now let's see how we can incorporate the business knowledge, incorporate the domain knowledge within LLMs. So once there are three ways to do it, through three ways to incorporate the domain knowledge. One is the prompt engineering. So the first one is we need to give conceptualize our prompts, contextualize our prompts so that it returns the relevant knowledge. So we need to give the prompt in detail. Let's say, for example, if you want to give a poem about a cat or a dog, then you need to mention that you are going to write a poem about a cat. So the prompt with the prompt engineering should be, you can say that imagine a ginger cat perched on a windowsill watching the rain that is falling outside, and the cat is both curious and content, feeling a sense of peace as it observes the world. And also you can say that write a short poem to capture this scene. Then this engineered prompt is more specific and provides content to guide the LLM towards a particular style of response, style and tone of the response, like peaceful observation and things like that. So it's more likely to result in a concise and evocative poem that aligns with your vision, that aligns with what you need. So you need to ensure that you give enough information, enough context for your prompt so that it gives you the result that you need. The next way of incorporating business knowledge is fine tuning. So what is fine tuning? Fine tuning is they will learn new skills. The LLMs need to learn new skills. How will they learn new skills? This is where you start with a base model and then you come up with at least 200 to 300 examples of things you wanted to know about it, or skills you want the base model to learn, and then you train with those examples. You train the model with those examples and you end up with a model that has more weights. And this is a fair approach, but it's going to be very expensive affair to do the fine tuning of the large language models. So and another option is where you can use the retrieval augmentation, which is called learning new facts. There is a difference between learning new skills and learning new facts. Learning new facts is you are going to provide the facts to the large learning model, and then it's going to retrieve the facts at the right time given the right context. So that is that is not that expensive compared to the fine tuning part of incorporating the business knowledge or domain knowledge to the LLMs. So this leads to the retrieval augmented generation, which is also known as RAG. So this is a way of learning new facts, and this is temporary in order to answer the current question that is being asked. So how does this work? It involves retrieval of information and sending that information to the LLM so that it can answer the question with the information. So with the facts that we provide, it's going to answer that information. So now let's see what the benefits are of RAG. So again, I went back to my question about who is the Prime Minister of New Zealand. But before asking this question, what I have done is I have fed the a new document which says that the current Prime Minister of New Zealand is Christopher Mark Luxon, who has been in office since November 2023. And also I have fed the facts that what our company core values are. So now when I have given the facts with the new document, now the question is answered correctly based on the facts that I have fed to the model. So now what is happening is with the RAG, you have updated the knowledge of the LLM, and also when I have fed our company's core values to the model, then the core values of our company, which is data engine, are nimble, quality, co-creation. We are all ears, progressive thinkers, and pragmatic. These are our company's core values. So that is what it has returned, and here it also returns the reference of the document that it has used to get these facts out. So it has access to the internal knowledge as well. So the limitations of the LLMs can be overcome by we can overcome the limitations of large language models by using the RAG technique. So how does that work? So retrieval, the RAG stands for retrieval augmented generation. So here we have the RAG architecture where there is a user input where I have asked what are our company's values. Now what it does is it goes and searches the documents that I have provided, retrieves the document based on the user input, and then it augments the prompt that I have asked with the grounded data, and this is sent to the LLM, and then based on this augmented prompt with the grounded data, the LLM retrieves the response, and here is the response. So that is how the retrieval augmented generation works. So it's all about the retrieval. So if you can retrieve the documents, then you can have a good experience in getting your answers correctly. That means you need to concentrate on retrieval, and that is what we are talking about today. So how do we do that retrieval? First of all, the traditional searches are based on keyword. So for example, if you search for something like underground activities, then the keyword search will not get the activities like scuba classes or diving classes or snorkeling activities. But when so that is the problem with the keyword search. That is the reason we would want to do a vector search which will get the answers based on semantic similarities. So vector based search which can find things based on semantic similarities. So vector based search is going to realize that the scuba activities or scuba classes, diving classes, and also snorkeling activities will come under the underwater activities. That is the reason we are trying to look at what vectors and vector databases is. Before we go to understand what a vector database is, we will try and understand what a vector is. So what is this vector? A vector in its simplest terms is a mathematical object or a quantity that has both magnitude and direction. By magnitude, what I mean is how much you move, and a direction means where you want to move, where are you moving. So it is often represented as an arrow, where the length of the arrow shows the magnitude and the direction of the arrow shows the direction. So for example, imagine you are at a party, you are going to a party. So you start at the party and you need to move to see your friend upstairs. Let's imagine that. So you take 30 steps forward because you need to go upstairs. You climb, let's say, 10 steps up, and then it may be on a staircase or something like that, and finally you take another 15 steps towards your left. Now that is where you meet your friend. This movement can be represented as a vector. A vector, like I said, in its simplest terms, is a mathematical object that has both magnitude and direction. So in mathematical terms, this can be denoted as a three-dimensional vector because we are considering movement in three different directions. First one is moving forward. It can be either backward, and you are climbing the stairs, so moving up, and then the other direction is left or right. So you have three different directions here. So each of these movements can be considered as being along a different axis called, let's say, ABC or XYZ. So each X represents one direction, Y represents another direction, and Z represents one direction. So, and the vector can be represented as, let's say, for example, V1 equals, because we took 30 steps forward, so 30, 15 steps up, 15, and then you went right right 10 steps, so it can be represented as 10, or depending on the direction, it can be minus 10 or plus 10. So in the case of machine learning, vectors play a significant role there, and they are used to represent and quantify features of things like your text, images, and even sounds. Let's look at a little bit more detail as to how vectors are represented. So I have here three sentences which says, I like roses, I like lotus, and I hate lotus. These are the three sentences. And in these three sentences, let's look at what the unique words are. We have 5 unique words. So that means you have I, like, roses, hate, and lotus. So the order is I, like, hate, roses, and lotus. So because there are 5 unique words, your vector is represented by is a 5-dimensional vector. So if we want to represent that in a vector representation, I like roses will be 1 for one I, like is like, because there is no hate, we are putting it as 0 in this order, and because there is roses, we are putting it in as 1, and then because there is no lotus, we are putting it as 0. So this I like roses will be represented as 1 1 0 1 0. Similarly, I like lotus will be, I like will be 1 1, because there is no roses or hate, these two are zeros, and then because there is lotus, this will be 1. And similarly, I hate lotus will be 1, because there is no like, it will be 0, because there is hate, this will be 1, and because there is no rose, this will be 0, and because there is lotus, this will be 1. That is just to give you an idea as to how to represent a 5-dimensional vector. Hope you get an understanding of what a vector means now. Now that we have looked at the vector representation, now let's look at vector databases. So what are vector databases? Vector databases, they store and manipulate data in vector format. The vector database organizes and stores data in a way that lets you find the specific information you are looking for faster. And this is achieved by indexing. What is indexing? Indexing is a process that makes the retrieval of data quicker. So remember the party that where we walked. Remember the example of the party that where you walked to find a friend. Now imagine you are hosting a big party and you have a list of all your friends you have invited. You know how close each friend is to you, not just in terms of distance, but also in terms of their habits, their attitudes, their hobbies, and how often you go out with, and other attributes like that. This closeness can be represented as vectors, similar to how your steps at the party were represented. So, a vector database is like a huge party organizer that can handle millions of these friend lists. So now you might have a question: what is the need for indexing if it is just a friends list? Now, when you are trying to find a specific friend on your list, how do you go about? If you just have a list, you don't want to read all the friends through the entire list, do you? So, especially if it is very long. So, this is where indexing comes in. Indexing is like sorting your guest list by a certain characteristic. Say, let's say, for example, the first letter of their names, or so you can find the letters, find your friends faster. So, how do vector databases index the list? So, just like sorting your guest list, indexing in vector databases a map or a guide pointing to where each friend resides on that list. So, when you want to find a friend or a group of friends who share the most common interests, for example, few of your friends like doing yoga, and you want to find only the friends that who like yoga, similar to your interests, then you would look for them based on their shared interests. So, based on their shared interests, like who likes yoga. So, in the vector database, this similarity is determined by a measure, and like how we measure distances between two places. And in the case of vector databases, indexing works by comparing and grouping similar vectors together. Now that we have looked at what vector is and vector databases are, now let's have a look at a term called vector embeddings. Vector embedding is some input like a word or a sentence or a paragraph, etc., and then it sends it through some kind of an embedding model, text embedding model, and then as a result it gets a list of floating points, point numbers. Okay, then there are a lot of embedding models, and different embedding models output different varying lengths of they vary in their lengths, and as seen in the table here, where here SBERT embedding model which encodes up to 400 words, and the vector length is 768. And when we look at OpenAI ADA model, ADA 002, that takes up to 8192 tokens, and the vector length is 1536. And Azure Computer Vision takes either image or text, and then the vector length is 1024. In the recent years, there have been several embedding models that came up based on these LLMs. OpenAI ADA is one of them, and Azure Computer Vision can encode image or text. We have seen that RAG architecture is as efficient as your data retrieval process, right? So for this, indexing your data source can be optimized for RAG process. So a search index, now let's look at a search index. A search index describes how your content is organized. For example, a library contains many books, but because the librarians create a catalog of these books and put them in those designated places, it is easy to find a book that you need. So in this scenario, the catalog is a search index. So if you look at this diagram here, this is an index for a excuse me. This is an index for a keyword search. So when I ask what are your company values as a user input, if we create an index for keyword search, then what happens is the index helps you to augment the prompt with the grounded data. So this index will enable you to search for content based on keyword search, and then provide the grounded data to LLMs, and then the LLMs will give the response, will provide you with the response. This is a keyword search. Now if we look at the vector index, so a vector index is a special way of organizing data, particularly for information retrieval tasks. Okay, so imagine you have a giant library, and but instead of bookshelves with titles, you have all the books piled in a massive room. Finding a specific book would be very time consuming. You have to go through all the books. So vector indexes come in handy when you are dealing with vector data. So these are essentially multi-dimensional representation of information. So think of them as points in a high dimensional space where each dimension captures a specific aspect of the data. For instance, an image vector might contain values of color, brightness, texture, and in different regions of the image, right? So here is how vector index helps with searching with such data efficiently. So indexing for similarity. So the vector index doesn't store the data itself, but it rather organizes the locations of similar data points in that high dimensional space that I mentioned before. So instead of searching through every single book or data point in the library, the index can quickly point you the areas where books on similar topics, or similar data points, are likely clustered together. So example, when you watch one kind of movie, you get recommended movies which are of similar which are based on certain similarities. So imagine that each movie can be represented as a vector where different dimensions capture aspects like what is the genre, actors, director, and sometimes user ratings as well. So here what we are seeing is when we have a sentence like that, children played joyfully in the park, and there is another document called kids happily ran around in the playground. These are two sentences. So how the vector index is created is based on this chart here, where it groups children and kids to be similar based on the vector index that it creates, and park and playground as similar in this case, and then joyfully and happily are placed together. So the vector index is created based on this one, and then when you search for kids, children also is considered, whereas in keyword search that does not happen. So by organizing similar data points close together, vector indexes enable fast and accurate retrieval of similar items based on their context, making them crucial for various applications like recommender systems or image and document search and other natural language processing tasks. Now let's look at improving the performance of RAG. So ensure that the quality of the context provided to the LLM is of high quality. Clean up your source data and ensure your data pipeline maintains adequate content, such as capturing relevant information and removing unnecessary markup. We have heard a lot about garbage in and garbage out. So we need to make sure that we carefully curate the data used for retrieval to ensure it's relevant, accurate, and comprehensive. And the next way to improve the performance of RAG is by tuning your chunking strategy. And chunking really matters. So experiment with different text chunk sizes to maintain adequate context. The way you split your content can significantly affect the performance of your RAG system. analyze how different splitting methods impact the context's usefulness and the LLM's ability to generate relevant responses. And another way is to filter the vector store results. So implement filters to refine the results returned by for the vector store, and ensure that they are closely aligned with the query's intent. Use metadata effectively to filter and prioritize the most relevant content. And another way to improve the performance of RAG is to experiment with different embedding models. Try different embedding models to see which provides the most accurate results, and which provides the most accurate representation of your data. And also consider fine-tuning your embedding models to better capture your domain-specific terminology and the nuances. So these are the some of the ways to improve the performance of RAG, but these are not it is not limited to only these. There might be some others out there. I just picked a few of the things that you can use to improve the performance of RAG. Now I think it's time for demo, demo time. So let me start the demo, which I'm going to show you on Azure AI search. So here I have my Azure OpenAI Studio, and in the Azure OpenAI Studio you can deploy all these models in various regions. See, you have the text embedding ADA 002 model, which we are going to use, and also I think I'm going to use the GPT-35 Turbo. So these models I have already deployed, and if you look at the deployments, I have 3 models here, which is the GPT-4, GPT-35 Turbo, and text embedding ADA 002 model. So now if I go to the chat application and try and try and ask something, before I ask, there is a system message template which I have earlier mentioned to you, which you can use. There is already a default one, so I'm just going to choose a default one, and so here is the system message, and you can type a message saying that you are an AI assistant helping answer questions. Okay, so that's my system message that I'm giving to the model. And here I'm asking what is the best practice for, let's say, for implementing Azure Active Directory. And this it is going to answer, because this model, the GPT-4 model, has been trained with previous data. I think the training data is as of December 2003. So it is giving all the best practices, and then it has given me the about 10 or 12 best practices. But if I ask what are my company values and hit enter, now it says that as an AI, I don't have access to your company's internal information or documents unless you provide them. And then company values are typically, and then it gives you whatever it has been trained on in the previous this thing. So it is more of a generalized response rather than your company values. I'm just going to change this model to GPT 3435 and clear this chat. Now here I have my Azure AI search resource, and what I'll do is I'll just import and vectorize the data that I have as a document. Maybe let's first look at that document that I'm going to feed in. So it says there is one sentence for getting the model to understand that the Christopher Luxon is the Prime Minister of New Zealand, and also I have given in the same document I have given Data Engine company core values, where Data Engine is the company that where I work for, just to get it to answer what the Data Engine values are. So I'm just closing this document and then trying to import. You can either import data or use import and vectorize data. So import data, what it does is it just creates a search index. It does not create any embeddings or vector search. So because I want to show you vector search, I'm just import data and use the blob storage. That's where my document is. I have already previously uploaded the document that we have seen, and the blob storage account name is that, and then my container name is called documents, and there is no folder within the document, so I'm just going to use that. And then the next step is your vectorizing your text data. So for that you need OpenAI service, which I have chosen as this one, and or you can create a new OpenAI service from here as well. And then in the model deployment, you can choose text embedding data, which I've shown earlier, which we have chosen, and then leave the default authentication type, and then I acknowledge that connecting to an Azure OpenAI source will incur additional costs. And then because I don't have, for this purpose, because I don't have any vectorizing images and also enriching data with AI skills where I need to extract text from images, I'm just going to go and then enable the semantic ranker. So semantic ranker uses deep neural networks to provide relevant results and answers based on semantics similarities, which is and then schedule this. You can choose the schedule once every 5 minutes or 10 minutes or 30 minutes or hourly or daily or custom, and I'm just choosing it for once because my documents don't change that often. And then you can name this vector as vector DSS 2024. Sorry, must start. Okay, only lowercase is allowed for some reason, so I'm just going to DSS 2024. Okay, so now I'm just going to create it. So now it's creating Azure AI search notification, creating indexer vector. We can, once these are created, we can see those and then see how many documents have been indexed and stuff like that. So let's have a look. Yeah, now creation has succeeded and it says start searching, but here when I look at the index, it is not showing me any options. So now I think it took up time to refresh. So now you can see total storage and vector index size of the total documents folder. So now if I try to ask for what are my company values, so if I search here, so now it's going to the search index, going through that, and then now it is saying, because I said Data Engine, it is giving you the answer saying that Data Engine company core values are nimble, we move fast, but think. So you see how it is giving you, and it is also giving you the chunk ID based on the chunks that it has created, and it is also giving you the parent ID, the actual document, and also the other chunk that I have, and then what is the title of the document, and metadata data storage path. And now here you can see the vectors that it has created, the text vector embeddings that it has created. So this is what I wanted to show you. Now what I can show you is, if I go back to my OpenAI document, OpenAI, Azure OpenAI Studio. Now what I just want to replicate and show you the same functionality. So here if you come and you can add your own data based on the index that you have created. So I can say add a data source, and then here I can say, because I have already created the index in Azure AI Search, I can just choose the Azure AI Search. Otherwise you can always upload files and then try and get the vectorizing part of this or part of a web address and things like that. But for now I'm going to choose Azure AI Search, and then it is automatically recognizing my search service because there is only one search service. And here I think there are a couple of indexes, so I'm just choosing the index that I have created, which is the vector DSS 2024, and add vector search to this source. Let's add it, and then when we already have created it, so we don't need to add it because it's already added. So let's go next, and then here you can see that you have a keyword search and a semantic search. So I'm just going with semantic search because of the vector search that I have already created. And semantic configuration is this semantic configuration which has automatically created when we imported and vectorized the data in our Azure AI Search. And here if you go, you can go with API keys, and then go next and review and finish, and then you will have save and close. Now that is done. Now let's try and use the our famous question again. What are my company values? And so here once I gave the what are our company values, then it has recognized based on the vector search index that I have added here. It is showing that it is nimble, quality, co-creation, we are all ears, progressive thinkers, and pragmatic. So that was what I wanted to show you as part of the demo of vector search and the vector embeddings and the RAG part of it. Now thank you for attending and my session so far. And your feedback is very important for me to make improvements in my presentation. So please do scan this and then provide your feedback, please. And also I thank all the organizers and the sponsors of Data Science Summit Machine Learning Edition. That's it from me now. Thank you so much.